Alright, so it's time to talk about calculating things with regard to a transformer. And these kinds of questions come up really often on the IGCSE exam. So in any case, even if you're not concerned about that, you'll want to know how to convert voltages and current and so on in a transformer. So here we go. We've got two formulas that are related to a transformer. This is the main formula, and then this one also. Basically, this will tell you what happens to the current and voltage in a transformer if you assume that the transformer operates at 100% efficiency in converting the alternating current from this coil to this coil. Of course, it's not going to be 100% efficient, but it's pretty close. There's not a whole lot of loss of energy in a transformer, so you get most of your energy out again. So this is a reasonable assumption, but it is a little bit oversimplified. So what do we have here? Well, let's look again at the diagram. We have a primary coil and a secondary coil. In the primary coil, you have some number of turns of wire, so each loop here is a turn, so you could add those all up, count them. Same thing here, each loop is a turn, so you could count those all up. So N sub P stands for the number of turns in the primary. The P is for primary. N sub S, number of turns in the secondary. V sub P would be the primary voltage, and then V sub S is the secondary voltage. So I sub S, secondary current, I sub P, primary current. Okay, so those are our symbols that we're talking about here. So if we look at this, our first equation says that the ratio of the voltage in the primary to the voltage in the secondary is going to be equal to the ratio of the number of turns in the primary to the number of turns in the secondary. So let's just say I had 100 volts. I'll go ahead and write that in. Let's say I have 100 volts in the primary, and say I have 10 turns in the primary. I mean, that's a really small number, but we're just doing this for the sake of demonstration. And then say that I have 5 turns of wire in the secondary. Well, since we're doing a ratio here, 100 is to X as 10 is to 5, and the answer would be 50. So basically, if you had 10 turns in the primary coil and 5 turns in the secondary coil, your primary voltage is 100, then your secondary voltage is going to be 50. So half the number of turns means half the voltage. All right, that's pretty simple. In this case, it's a little bit different. Let's just say that we have 100 volts again in the primary. Let's go ahead and say that it's 50 volts in the secondary like we had before. And then let's say that the current is, we'll just say 1 amp, just to make it simple. That's a big one. So then the question is, how many amps would we have in the secondary? Well, 1 times 100 equals something times 50. What times 50 is going to be 100? And the answer is 2. So you can see that the current is inversely related from one side to the other. So if the voltage drops by half, then the current is going to increase by a factor of 2, or double. So if the voltage goes 100 to 50, then the current goes from 1 to 2. It doubles. Voltage halves, current doubles. So they're opposite, they're inversely related. All right, so that's your two formulas that we're going to be working with when it relates to transformers. So let's take a look at a couple of practice problems and work them out really quick. All right, so we have here a problem in which a primary coil of a transformer has 1,000 turns of wire with an EMF of 500 volts, and the secondary coil has 100 turns of wire. And the question is, what is the EMF in the secondary coil? So let's scoot this up a bit, give us some space to work with. You might remember that the formula is voltage of the primary divided by voltage of the secondary is equal to the number of turns on the primary divided by the number of turns on the secondary. So how are we going to set that up? Let me just scoot over here. Bam. So the primary coil, in this case, has 500 volts. Sorry, those zeros are not very good. They look like sixes. Alright, just fixed that there. So 500 volts on the primary. Our unknown is the number of volts on the secondary. And then we know that the primary coil has 1,000 turns of wire, and the secondary coil has 100 turns of wire. So we're going to skip rewriting all of this and just get down to the point, because we can tell that this is a difference of a factor of 10. So if the number of turns of coils, the number of turns in the primary coil drops by a factor of 10, then the voltage from the number of the voltage from the primary to the secondary is also going to drop by a factor of 10. Sorry. Anyway, so a factor of 10 difference means that X in the secondary coil would be 50 volts. Okay, so that's the answer for the first part. How about the second problem? Alright, so I'm actually going to skip writing it all out. We'll just jump straight to the point because it's the same exact sort of problem. And we'll just look at this here. So in this case, the primary coil has 50 turns and the secondary coil has 200 turns. So that's an increase of a factor of 4. So this is 4 times bigger than that, which means that the secondary voltage is going to increase by a factor of 4. If the primary voltage is 12, 12 times 4 is going to be 48 volts in the secondary coil. Alright, moving on to the last problem here. This one we have the other formula. We're going to do I sub p times V sub p is equal to I sub s times V sub s. So let's just plug in the numbers. Primary is 110 times 3, which is going to equal to X times 220. All right, now as this is increasing, the voltage increases by a factor of 2. So that means the current is going to decrease by a factor of 2. So without putting this all into my calculator, you can verify it if you want. X is going to equal 1.5 amps in the secondary coil. Okay, so there's some practice problems to solidify the idea of how you calculate using these formulas and using transformers. And just one last concept just to make sure it's clear. I wanted to talk just very explicitly about a step-up transformer versus a step-down transformer. And those are two different kinds of transformers. There's only two, basically, as far as we're concerned. A step-up transformer is going to have fewer turns of wire in the primary coil and more turns of wire in the secondary coil. So let's zoom in on that really quick. Here we have a transformer with only 5 turns of wire in the primary coil and 20 turns in the secondary coil. There are some numbers there that you can look at if you'd like. The power stays the same on both sides. That means it's 100% efficiency, or close to it. So this is what's called step up, because you can see that the voltage starts at 100 volts, it ends at 400 volts. So the voltage has been stepped up by a factor of 4. All right. Smaller number of turns in the primary, larger number of turns of secondary. That's a step up transformer. All right. The other kind is called a step down transformer, and this kind is basically the opposite. You have more turns of wire in the primary coil, you have fewer turns of wire in the secondary coil, so the voltage is going to drop down because, of course, since there's more turns here, less turns here, that means there's more voltage here, less voltage here. So This is called a step-down transformer because the voltage gets stepped down. All right? So that's it. Now you know what you need to know about transformers. Thanks for watching this video, and we'll catch you in the next one.